Hi guys. Today what we're going to learn is how to solve simultaneous equations using the elimination method. Now, the first thing we need to think about is how we generally solve equations. So if I have an equation, let's say x minus 4 equals to 8, and I've got another equation, x plus 5 equals to 13, can we solve these equations? What you'll probably say is yes, we can add 4 to both sides, and then we'll end up with x equals to 12, and here we can minus 5 from both sides, and then we get x equals to 8. And the reason we know that x equals 12 here is because when we substitute 12 into there, 12 minus 4 gives us 8. But what we're also doing is we're moving all the numbers from one side to the other and just trying to find the letter by itself. Now, that's kind of the idea of what we need to do today. When we are solving equations using the elimination method, we'll be adding our equations with our other equations, similarly to what's happening here. Now, let's have a go at one of our examples. So we've got this equation, minus 4x minus 2y equals negative 8. And we've also got this other equation, 4x plus 3y equals to 10. Now, generally when we have two equations, what we like to do is we label them. So I'm going to call this equation 2. I'm going to just give it a green pen. And I'm going to call this equation 1. Sorry, that's too messy. Okay, so what we've got here are two equations which we know are equal. We know that negative 4x minus 2y gives us negative 8. And we also know that 4x plus 3y is equal to 10. Now, when we are using the elimination method, what we are trying to do is eliminate a whole letter out from these equations. How we can do that is generally by adding or subtracting one equation by the other. There is a helpful thing you can do to remind yourself when you need to add and subtract, but we'll show you just practically why each method works. So in this problem here, can we see we have 4x and we have minus 4x. The numbers are the same size, but one's a negative and one's a positive. When the signs are different, you need to add. Okay, so what we'll be thinking about is adding equation 1 to equation 2. Now, when we are adding equation 1 to equation 2, we're not just going to be cramming everything together, because what we have is a left-hand side on equation 1 and also a right-hand side of our equals sign. On the flip side, we also have a left-hand side of equation 2 compared to a right-hand side of equation 2. Now, the thing about our left-hand sides and our right-hand sides is that we know we are trying to eliminate our x's because they're the same size. If we try to add 4x with negative 4x, we can see that it cancels out. If we try and add negative 2y and positive 3y, we'll be left with something else. So we are not eliminating y's, we're actually eliminating x's at this stage. So let's write this out. If we add 4x with negative 4x, that's just going to be 0. If we add 3y with negative 2y, that's just going to be left with 1y. And so that's all our left-hand sides done. And then when we add negative 8 to 10, we end up with positive 2. So what we just get here is y equals to 2. Now, what we do at this stage is exactly the same as what we did in our previous substitution method, where we then just need to sub y equals 2 back into any of these two equations. Now, I know most of you don't like dealing with negatives, so let's just sub it into equation 2. And so 4x plus 3 times 2 gives us 10. We know that's going to be 6, so 4x plus 6 equals 10. And then at this stage, all we're doing is solving our equation. Minus 6 from both sides, then we end up with 4x equals 4, divided by 4 from both sides, then we end up with x equals to 1. So we have found the pair of points that can substitute into both these equations for this to be true. And how we solved that was because the signs were different, we had to add them together. Now, we'll do another example, but this time where the signs are the same. So we've got x plus y equals to 5. We've also got 2x plus y equals to 7. And like our first equation, we're going to label them number 1 and equation number 2. Now, this time, what we notice sorry, I didn't realize it wasn't in the camera. So we've got two equations, x plus y equals 5 and 2x plus y equals to 7. Now, this time, when the signs are the same, you need to subtract the equations. Okay, so this time we are going to subtract equation 1 from equation 2. Now, when you are subtracting your equations, you have to be really careful with your negatives. In this example, we don't have any negatives, but sometimes if this is like minus x and we have 2x minus x, then two negatives will make a positive, and you're going to have to deal with situations like that. Okay, so let's just subtract equation 1 from equation 2. If we have 2x minus x, we'll be left with x. If we have y minus y, they're going to cancel out. If we're going to have 7 minus 5, that's going to give us 2. And so we've already got our answer nice and easy through our elimination method. We've got half our answers. Because the second thing we need to do is we then need to substitute x equals 2 into either equation. I think equation 1 will be a little easier, because if we then substitute 2 plus y equals to 5, minus 2 from both sides, we end up with y equals 3. And so what we can do is, again, check if these work. 2 plus 3 equals 5. 2 times 2 is 4, plus 3 equals to 7. So these are my solutions to my simultaneous equations. And how we found that was through elimination.